Welcome to this explainer. Today, we're jumping right into Grade 7 Python Programming, Unit 8, Lesson 1. And just to make sure we're on the exact same page, we are reviewing Lesson ID STEM-Python-STEM-Python Unit-08-Lesson Pack-01 String Manipulation, Review and Transfer Video Overview, which is exactly titled String Manipulation, Review and Transfer Video Overview. All right, let's dive straight in and look at a fundamental rule of Python that completely changes everything you might think you know about text data.
So, let's kick off this review by testing a super common misconception among 7th grade programmers. A lot of people think you can just swap out a single letter in a string using an index assignment. Like, imagine you've got a string variable called word, and it stores the text Python. What actually happens if we type word bracket 0 equals J to try and change that first letter from a P to a J? Honestly, it seems incredibly logical, right? You just target the piece you want to fix and swap it out.
Well, if you actually try that in Python, it crashes. You get this exact message, a type error stating that the string object does not support item assignment. Now, what's really fascinating here is what this error is telling us about how Python actually treats text behind the scenes. See, strings just don't behave like physical objects. They aren't like toy cars where you can just pop off a broken wheel and snap a new one right on.
And according to the official Python documentation, this happens because strings are immutable. This is an absolutely crucial vocabulary word for your unit test, by the way. Immutable literally means Python strings cannot be changed once they are created. So once that sequence of characters is locked into your computer's memory, its contents are totally frozen forever. You can't alter even a single character.
But, this brings up a really great question. If strings can never ever be changed, then how on earth do string methods actually work? Because we use things like .upper or .replace all the time in our code, right? So how do concatenation operations or slicing even function if the original text is supposedly frozen solid? Well, the official Python documentation gives us the evidence right here. Every single time you slice a string, concatenate using the plus sign, or run a case method like .upper, Python doesn't actually change the original string. Nope, instead it returns a brand new string as the result. So the original string, it stays exactly the same, safely tucked away in memory, and a fresh, modified copy is just handed right back to you to use.
Worked example, saving the results. Let's look at a quick example to see how this rule completely changes the way we have to write our code.
This comparison brilliantly illustrates the difference. If you just type word.upper, that new uppercase string is mathematically created by Python, for sure. But it immediately flies away into the void because you didn't catch it. The correct Python way is to actually assign that newly returned string to a variable. By typing loud_word equals word.upper, you're saving that brand new copy so you can actually keep it and use it later in your program. So, let's circle back to our very first problem, right? Trying to change Python to Jython. The official docs show how to do this perfectly. If we can't change Python to Jython in place, we just build it. Step 1, we start with our string. Step 2, we take the slice word 1 colon, which just grabs Ithon. And then step 3, we concatenate a literal J to the front. By gluing J and Ithon together, we get a brand new string back, all without breaking Python's strict immutability rule. Pretty neat, right?
Your turn. Predict the output. Now it is time for a transfer challenge to put you in the driver's seat and see if you can apply these rules to a new scenario.
Take a really close look at this code. If word equals Python, what is the output of the expression word:2 plus pi? Think about what that slice, omit start to 2, is grabbing, and what that plus sign is doing. What new string gets created here?
Okay, so the crucial point here is understanding that slice. The answer is pipey. And why is that? Because word up to 2 grabs everything from the beginning up to but not including index 2. That gives us a capital P and a lowercase y. Then, gluing the literal string pi to the end creates that brand new string pipey without touching our original Python variable at all.
The absolute golden rule and the ultimate takeaway for your unit review is this exact quote straight from the Python documentation. If you need a different string, you should create a new one. It's that simple. Never try to modify the string directly. Just use your slices, concatenation, and methods to generate a new string, and always make sure you save it to a variable. So as you head into your test, I want you to ask yourself, what other data types have we learned about that might also be completely unchangeable behind the scenes? Keep that in the back of your mind, and happy coding.